This conference will now be recorded.
Okay, let's get started. So thanks for everyone to joining this call. First, I'd like to go over the last meeting's note. So last time we kind of discussed about two different concepts. One is the traditional real heat exchanger type, and then we also introducing the new type, which is called hybrid solutions. Um, and John made some presentation today to talks about what's the hybrid rack concept going to be looks like, and some preliminary study that he done. I already pulled his slide. I'm kind of waiting for him to join this call, but if not, then I'll try to present it on behalf of him. And we also talk about some of the specifications, what are the application. We also talk about the application for real heat exchanger. And we also talk about, passive versus active, and passive seems to be, have to overcome the pressure drop with, through the real heat exchanger. And we prefer that active would be um, more efficient than passive. We also talk about hybrid solution and what would be the kind of power target that the hybrid solution could be. We talk about around 30 kilowatts and ish. Um, and we also talk about what will be the kind of use cases for the hybrid solutions. We haven't really talked detail on the pressure drop on the real heat exchanger. Um, but this is something that we want to continuously discuss about, and writing a spec around that, the pressure drop or the requirements for this concept. Before we go on, do you have any question about the last meetings?
Hey, this is Jason Zeiler. I just had a quick comment. I'm not quite done the example of the chilled water to rear door heat exchanger. We had some discussions just internally about the customer case that I wanted to share, so I might omit some of the details about the specifics of what they're doing in their data center. But definitely, I can still provide a diagram and some high-level explanation as soon as next meeting. So I'll kind of apologize that it's not ready today, but wrap something up for next meeting.
Okay, thank you. I mean, yeah. I mean, we can talk about a little more detail on the use cases or um, for from you in the next meeting. So I actually um,
Could I say something about the last meeting minutes? I'm a little concerned about the stated preference for fan-powered rear doors. Is that considered a consensus, and we're going with that? I really think it's not an either or. The passive rear doors are very good at lower loads, and as you get to higher densities, you go to the fan-powered rear doors. But I mean, clearly, there's a place for both of them, in my opinion, and we have lots of experience.
Hmm. Can you tell me a little bit more about passive and active, and you mentioned about the passive might be good for the loading. So how much the low loading are you think that the passive could be more beneficial?
I don't have those numbers in front of me, but I think it's somewhere around 12 to 20 kilowatts. We've used the passive rear doors, and as we go, towards 30, then we're looking at the active rear doors.
Mm, mm. Yeah, so I'm not trying to limiting as we go on writing the specifications around the door heat exchanger. I'm not really limiting to active versus passive. We probably want to um, write a specification around both the concept. But we are currently kind of dealing with three different concepts. One is a passive active real door heat exchanger, and one is a hybrid. Is that clear? Hello?
Oh, is that a question to me? I mean, the hybrid was a was the hybrid that Facebook described, which is a fairly unusual application of hybrid. But I mean, there are quite a few hybrids that use a rear door in combination with cold plate technology,
Mm-hmm.
which is I think a more common hybrid approach where anytime you have onboard cooling that doesn't satisfy 100% of the load, you look for another method to capture the remaining heat. And one solution that's used pretty widely in the HPC area is rear door or interstitial coils.
Yeah, so I think the main kind of intention for bringing the hybrid solution is more, to fitting into air economized data center where we're making a transitioning from the air economized data center to the liquid cooling data center. And this hybrid solution can maybe supporting the high power chips but still using the air liquid heat exchanger to dissipate the heat from the IT. Is that so? And the real heat exchanger is more, going into, the data center that has a facility wattage available.
Right.
So,
I mean, I think that the thing that took me a while to understand is that your hybrid, you're actually cooling the water rather than cooling the air as the air passes through the rear door. And that it took a little while to get my arms around that, but now I got it.
Okay. So, let me share the bare bone for our specifications. So I don't think I haven't shared this to everyone yet, but this is just really the bare bone. So, the scope of the work and overview and some physical dimensions, and I'm thinking to discuss about what are the concept, the kind of description of what is active and passive rear door heat exchanger, and then also what is it mean by hybrid rear door heat exchanger, and some manifold that associated for hybrid rear door, and some of the data center environment condition that including temperature related humidity, and so also talks about heat exchanger dimensions, depth, placement, locations, cooling power requirements, and pressure drop delta T, and fans serviceability, and some regulations, environmental and regulations, and requirements and reliability. So I kind of put the kind of general high level sections, but if you guys feel free to add or recommend to adding more descriptions or modify the descriptions as needed. And I'm trying to use this template to start writing our specification around these three concepts. And I'll try to share that to everyone by today, or the latest going to be tomorrow. So, any questions around this template? And honestly, I think we've been talking about some of the section. Like we also talk about the temperature ranges and humidity ranges. I think humidity range is more relevant to the hybrid. I think active and passive had a much wider range of the humidity that can be accommodated, and it's not sure about that. That we should be talks about some pressurizations or anything that's non-thermal, non-temperature and humidity related data center environment. So maybe I'll ask this community that what data center environments are going to be necessary to specify it in this spec. So I need some more help on, what are the conditions do you think is going to be needed in order to make this concept more successful and more adaptable. And we've been talking about a lot on heat exchanger. We haven't really come up with the, lot of sectionals here is also depending into other ones. Like for example, cooling power also depending on the pressure drop. But I think my intention is to really define what is the maximum pressure drop that heat exchanger require, and then also what is the maximum depth, or what is the maximum cooling power that based on what we define in the pressure drop could do, and delta T could be associated accordingly. Our current data center is about 22 Fahrenheit delta T, so that's pretty much our delta T requirement at Facebook. I would like to hear that this 22 is more achievable for other company, or in community perspective. Serviceability. I can't really think about too much things about the serviceability at this point. Only thing I can think about is how to, you know, how to make the rear door heat exchange to be more serviceable. I think we talk about the hinge door. If you have any other concept how to improve the serviceability, I'm open to hear more about this option. Some regulations, I think those are, I also need some help from the community that, what type of regulations that you guys dealing with, and what are the things that we need to put it on. So overall, I think we are going to write the specification together, and I will need a lot of help from the community that what um, area we should be specify in this document. So let's kind of show you what John's made it. Maybe I'll try to present it on behalf of him. So one of the thinking that we can utilize the hybrid cooling solution is on the GPU rack. Currently, um, can you guys see the screen?
Yeah, you can see it.
Yeah, so I'll definitely will try to post this slide into the wiki so you guys can find this document. But generally, one of the thought we have is that using the hybrid cooling solution in a GPU rack. Currently, we have about a socket GPU that goes into the rack, and this is kind of the overview of the GPU rack. The number of the GPU, and those are just kind of the arbitrary number. But if we kind of populated the GPU and the head nodes, then we are kind of having 8 GPU rack and 8 head nodes that will be roughly about 34 kilowatts dissipation from the rack. And each of the GPU might be consuming about 400 to 500 watts. And our initial study was kind of based on 450 watt, which is kind of the average between 400 to 500. And we are trying to looking into that, whether this solution can be stretched it up to 500 watts in the future. So the idea is that the GPU can have the cold plate that's attached on top of the GPU, and then which is kind of the liquid cool, and that's connecting to the rear door heat exchanger that the liquid will be passing through, and then liquid passing through from the cold plate, and then air from the IT will chill the water, and then circle back to the chipset. And we're kind of using about 225 watts ancillary power for air cool. This is mainly from the fan power. And since we're kind of thinking the head nodes might not be required the air cool, might not require the liquid cool, and we're just assuming that only the liquid cool on the GPU, so it's going to be around 84% of the rack power will be dissipated by using the liquid to cool the GPU, and the rest of them are air cool. The caveat is we don't have a CDU here. There might be a chance that we might have to have CDU in the rack, which requires maybe 4U space. But we just want to kind of use this as this concept as kind of illustrations of how we are thinking about using the hybrid solutions. So before I go to the next slide, do you anyone has any questions around this?
No, I would say general, just for a comment. Sorry, this is Jason from Cool IT. Quick math on running the two GPUs in series. So for an example, our cold plates will usually see a rise of 0.05 Celsius per watt. So I would imagine that we would see a 22.5 Celsius rise over each GPU and 45 Celsius rise over both in series. So just something to keep in mind, that whatever the T case max is of those GPUs, say it's 80 Celsius, we'd have to subtract 45 Celsius from that, and then that would equal the liquid temperature we would want to see heading towards the GPU. So really that would be 35 Celsius. That's obviously limited by the air, but I think the hybrid solution in that case, that's exactly how we use this for, is high heat loads for maybe maximum GPU capture, and then also using the active rear door to capture the other components. Yeah, just something I always like to throw out there right away is what the expected liquid temperatures need to be.
Okay, yeah, thanks for pointing out. So yes, I mean for the cold plate solutions wise, I mean for GPU cold plate solutions, right, we also need to consider about series and parallel solution. And since there are 8 GPU, there might be a chance that that the liquid in series there will be some preheating from the another GPU, and something that we should be considering on the size of the rear door heat exchanger and also the layout of the IT. But the main benefit I would like to point it out here is that the hybrid solutions is kind of meant to be not only for the 100% air cool or 100% liquid cool, is more, some portion of the rack will be liquid cool and the rest going to be air cool. And without depending on the facility water in the data center. Any more questions?
Yeah, I mean, I was curious. You mentioned CDU, and I know that Cool IT has a fan coil-based CDU that would be an alternative to the rear door, and maybe a better alternative. And I'm just curious if you explored just a simple fan coil arrangement rather than an active rear door to cool the water going to the chips.
So honestly, we are very in the beginning of evaluating this concept. So I mean, we haven't really looked at enough detail, but we are trying to see how this concept will be feasible into our data center before we are making a huge investment on the data center side.
Dale, it's Cam. The end issue with the heat exchangers that we currently provide is there's just not enough surface area to hit the approach temperature that they need. So the idea is if we can get a larger amount of surface area, we can drop that approach temperature. And also there's, as you see in this rack layout, there's just no space in it, right?
Yeah, I mean, honestly, if we start adding the CDU, then I think the rack power, based on this concept, might be not going to reaching to 34 kilowatts, because there's a chance that the one head node in the GPU might be removed, so there will be a quarter. But at the same time, we are trying to understand what is the size of the rear door heat exchanger and what is the surface area that we are going to need it to cool 34 kilowatts rack or a little bit higher than that. Kind of ish. So we're not really targeting to cool high power rack with the hybrid solutions. We certainly think that as the rack power go higher, facility water is certainly needed. But same time, we try to understand what is the balance between the rack power versus the facility water, and focusing on very specific applications such as like a GPU proxy. Yeah, but as I said, this is just an illustration. So this kind of highlighted on the concept. And we also assume that the head nodes is going to be air cool. But if there's a chance that the liquid cool, then I can see that the real door heat exchanger might be a more feasible solutions if all goes to the liquid cool. So, so this is just kind of a little bit more detail. The loop connections, as I said before, so cold plates on the GPU will go to the hot manifold and then go through the rear door heat exchanger, and then and maybe if there's a CDU, then you pump through the CDU and going back to the cold plate, cold manifold, and then circle back to the cold plate. So this is mainly that cooling the GPU or cooling the hot components inside the rack, and which is used by the liquid cool. And we haven't really defining that where the manifold and where the fans located. And right now we put the fans in the IT, but we also can discuss about the fan goes into the real heat exchanger or uh, or or um, or stays in the IT space, and where the manifold and then where the loop and the pipe and all that detail needs to be defined in the specification, and we like to have community help. I'm requesting the community help to defining these specifications. I think this one is kind of the last one, last slide, so functional. So as I said, we are currently thinking that if we fully populate, it's going to be around 34 kilowatts. And I heard that some of the companies also looking at even higher for the GPU. But mainly we are assuming that based on the 3U boxes of the GPU, that the worst case is that the rack power dissipation is going to be around 30 to 38 kilowatts. And if we're assuming that the GPU is going to be only liquid cooled, then it's going to be around 85%, 84 to 85% of the rack going to be liquid cooled, and the rest of them going to be air cooled. We assume that air through the real heat exchange is about 3,000 CFM, which is mainly driven by 22 Fahrenheit delta T around 34 kilowatts rack. And we assume that inlet is going to be inlet air to the rack is about 35 at sea level, and which is going to be approaching temperature up to the real heat exchanger due to the preheating is about 13 degrees C higher. So which means that the water temperature is going to be around the 51 degrees C. So this is the last slide. So as I said, the main the hybrid concept is very specific, focusing to the specific application that maybe the portion of the rack requires liquid cool, and we feel that the real heat exchanger could give us most largest the size of the surface area that can be fitted into the rack, and cool those chip the high power chips in the rack. Anyone has any questions about this slide?
No, looks good to us.
Hey, for those of us that are calling in rather than logging in, would those slides be available on the website?
Yeah, so I'll try to put, like I said before, I'll try to post this slide into our wiki sometime today or tomorrow, because I also need to share the specification template into there. So everything's gonna be accessible either by end of today or tomorrow.
Jacob, feel free to just shoot me a note if you don't have the time, and I'm happy to do it for you.
Yeah, do that. I'll do that. So those are pretty much um, the agenda. The last agenda is what topics do you guys want to talk in the next meetings? Sorry, next meeting. Do you have anything that have you guys in my mind that what are the next step or the topics? I think one thing that I can think of is maybe we can talk about, maybe Jason can help us to present some of the use cases, or is that is that Jason, are you okay with that?
Yeah, that works for us. I'll try to put together some kind of basic visuals. Really what I want to just convey is what we expect for the rise across each of the components, and really how all the systems are working together. So I'll try to get some real numbers, whatever I can share, and then share that with the group. But I think that would really hopefully solidify what our concept is of hybrid cooling with both active rear doors and direct liquid cooling.
Okay, awesome. And another thing is I'll try to put something together, because we've been discussed this a little bit on, some of the items around the heat exchanger definitions or specifications. So I'll try to put that into our specification document, and maybe I will share that to community for review. But beside that, is there anyone has any things in your mind to discuss in the next meeting?
Yeah, I think that the cold plate team has been talking about specifications that would cross over between the cold plate and the rear door team, and since your hybrid approach sort of automatically does that, it's a natural. And I think the things that we're talking about in terms of a consistent specification would be things like the wetted material list and water quality and treatment.
Okay. Yeah, I mean, there's some. I think I can see there will be some of the overlap, especially with the Coldplay workstream, in terms of when we started defining the water quality and then also the Coldplay design. But the I mean, some of the I guess I need to talk to the other workstream that the lead, how we should be making more common specification around that. I'll try to sync up with the foundation team, and I'll get back to you around that. But in generally, I think overall concept could be slightly different, because I think, in my opinion, they're more focusing on having the open loop corporate design that's more targeted to facility water data center, versus the hybrid solution is more like air cool data center. So I guess there's
No,
some.
the cold plate group is definitely not using facility water on the server side of the CDU. I mean, there is the assumption that the CDU will be served by facility water, but the water in the rack will definitely be a closed loop. And the designer, the cold plate team is at least at the present time is stopping at the server. So what's inside the server or what's inside the box can be proprietary, but what we're looking at is consistent connections and pressure and temperatures and those sort of things. So you'd have a multi-vendor solution of servers in the box, which I think would apply to your concept as well. In other words, if your rack used the spec from the cold plate rack, you would just be connecting the manifold instead of the CDU to the rear door.
Sorry, can you repeat the last one? Maybe the cold plate connecting to the manifold instead of CDU?
Yes. What I'm saying is that in your design, you would be connecting the manifold that connects the servers to the rear door to exchange the heat. In the simplest form, I mean, assuming that you didn't have a CDU. Well, I mean, to some degree, you have a CDU. You're going to have a pump between the servers and the rear door, but you won't have a second heat exchanger.
That's correct.
Okay.
So basically, you would. It seems to me that your work stream could, in essence, take the cold plate work stream spec and just apply a rear door instead of a CDU to the system or to the rack.
Okay. Okay. Yeah, I mean, I'll sync up with I think Austin, I think who's the lead for the work stream on the cold plate, and see how far he been defining on the cold plate design, and maybe if there's a commonality, I'll try to share what they define in the next meeting. Is that okay? I'll
Yeah,
try to
sounds good.
I'll try to follow up. And,
Makes sense. Just as an FYI, Austin is stepping out, and David Moss from Dell is going to head that one up now.
okay. Okay. So I'll need some contact info for David. I think I
I'll
can
go ahead
find.
and send you his email, Jacob.
Yeah.
I'll go ahead and make the introduction.
Okay. Thank you. Thank you, Mike. Is there anything you guys want to talk at the next meeting?
Nothing specific from us. I think I'll try to share as much as I can about our setup, but yeah, that's good. I'd be interested to see if there's anybody else that wants to cover any other topics.
Okay. So I mean, for I'll try to. I really want to get starting on the writing on the specifications. So definitely, I'll try to put something together in the spec. I'll start with this. I'll start with putting something on the spec on the document, and then I'll try to share with you in the next meeting for review. And also, we can talk about what are the other specifications that we need to be including in the documents. And Jason can share more details on the use cases. Awesome. So I'll try to summarize some of the notes and the next agenda. I'll try to post the slide decks and then also the template by today and or the latest tomorrow.
Perfect.
Awesome. Thank you, everyone. I think this.
Thanks, Jacob.
Thank you. Thank you, everyone. Bye.
Bye-bye.